Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 11th, 2026, about 5 days ago. It introduces GameDevBench, a comprehensive benchmark that evaluates how well agents handle the complex mix of code and visuals in game development, finding that even top models solve only about 55% of tasks. The paper is titled GameDevBench, Evaluating Agentic Capabilities Through Game Development. And as we'll see later, the gap between performance on gameplay logic versus graphics tasks is quite significant. So Figure 1 gives us a visual tour of the benchmark scope. The top row illustrates complex 3D graphics tasks, such as generating smoke plumes or rigging character equipment. Moving down, the middle row introduces 2D graphics and animation work, like creating isometric running cycles. Finally, the bottom row displays gameplay and UI mechanics, where an agent might need to code a tank that fires bullets or build a functional minimap. Alright, Figure 2 breaks down a specific example task to show what the agent actually faces. Here, the instruction asks for a UI minimap with player tracking. The top half displays the visual editor state, where the agent must navigate the scene tree, managing nodes like the player and mobs, and select the correct image assets from the file system. The bottom half then reveals the underlying code representation. Since Godot scenes are stored as text, the agent can solve this by editing these dense configuration files directly, which allows the benchmark to verify the solution deterministically. Well, while the previous figures showed a single task, Table 1 categorizes the entire suite of challenges in the benchmark. The largest group is gameplay logic at roughly 36%, which tests core mechanics like enemy AI states and collision detection. Next, graphics work is divided into 3D and 2D categories, requiring agents to handle everything from skeletal animation to sprite setup. Rounding it out, user interface tasks cover the final 16%, focusing on interactive elements like menus and HUD layouts. So, Figure 4 details the sheer variety of assets agents must manage. The bar chart on the left shows that PNG image files are actually the most common file type, far outstripping code scripts. The central pie chart confirms this heavy reliance on visuals, indicating that over 80% of tasks involve specific assets like images or shaders. Then, looking at the table on the right, the statistics under Gold Patch reveal that solving a task isn't simple. It typically requires editing 5 different files and writing over 100 lines of code. Alright, moving to the results. Figure 5 reveals exactly where agents succeed and fail. The left chart shows that most models score highest on gameplay tasks, which are logic-heavy, but struggle with 2D and 3D graphics, where visual understanding is critical. On the right, we see a divide in stability. Top-tier models maintain consistent performance across all editor types, whereas weaker models see their success rates dip significantly when working in the visually complex scene or contextual editors, rather than just writing scripts. So following those general trends, Table 2 presents the detailed pass rates for every model and framework tested. The columns for screenshot and video feedback are crucial here because they show just how much multimodal data helps. For instance, look at Claude Sonnet 4.5 under the Claude Code framework. Its success rate jumps from roughly 33% to nearly 48% just by adding runtime video instructions. This pattern holds across most top-tier models, with Gemini 3 Pro reaching the overall high score of 54.5% when equipped with both tools. However, the bottom rows reveal that open weights models like QN3VL still struggle significantly, barely cracking single digits. While the previous table focused on raw pass rates, Figure 6 introduces the economic reality by plotting success rate against the median cost per task. The dashed red line captures the general trade-off, showing that adding multimodal feedback usually increases costs. However, the data reveals a standout winner for efficiency in the top left corner. Here, Gemini 3 Flash Preview delivers high success rates for under 20 cents per task. In contrast, the purple markers on the far right show that, while OpenHands with Claude Sonnet 4.5 performs well, it is much less efficient, costing over $1 per task. Wrapping up, 2 key takeaways stand out. Game development provides a rigorous testbed, where code and visual assets are inextricably linked, yet even frontier models struggle without explicit visual feedback. This suggests that future progress in agentic artificial intelligence will depend on bridging the gap between reasoning about code and understanding the visual end product. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.